Today we are going to continue study of control valve calculus. Already we have seen there are three types of valves. One is quick opening, equal percentage and linear. These are all true only when the pressure drop across the valve is constant. Pressure drop across the valve constant. Then only this is true. Suppose you are having linear valve, means the pressure drop across the valve must be constant. This is the valve structure, cross section of the valve. Cross section of the valve. This is the inlet. Inlet will enter here. Outlet will come here. Already I told you that the flow rate will be against gravity. Against gravity. This is the seat gate and this is called plug. The shape of the plug decides the type of valve, linear, equal percentage or quick opening, decided by this plug. This is connected to the stem here. This plug is connected to the stem. This is the stem. This is the stem connected here. And already I told you that it is spring loaded. This is the spring loaded. Why? Because if the pressure signal is withdrawn, the valve position should come to original position. So the pressure will act against the spring. Act against the spring. So the spring is to regain original position. Spring is to regain original position. That's all. Another, in the stem there is a travel plate. Here we do not know what is the position of the stem. What is the position of the plug? We do not know. That will be indicated by this disc. One disc will be here. The disc and the scale will be there. That is called travel indicator and a travel plate. By using that, we can know the position of this stem. Position of the plug we can know. Here, this is the chamber. This is the chamber. In the middle, the flexible member is called diaphragm. Diaphragm. That is there. If the air input is top side, then it is called air to close. The air input is in the bottom. Here it is in the bottom. Here the air input is in the bottom, means it is called air to open. Both types are available. This is based on what type you have to select is based on the safety of the situation. Whether if pneumatic signal fails, whether valve has to be closed or valve has to be opened, depends upon the safety aspect. Chemical aspect we have to decide air to open or air to close. So this is sufficient. This is sufficient to know about the valve. Already I told you that there are three types of valves. This is the laboratory setup in the lab. Laboratory setup in the lab. There are three valves. Here the air input is the top. That's why this is air to close. Here it is in the bottom. Here also it is in the bottom. That's why these two are air to open. Air to open. Air to open. This is air to close. And this is equal percentage. The second one is quick opening, and the third one is linear valve. Here, this is the rotameter. To know how much flow rate through this valve, to note that there is a rotameter. To know the flow rate through the valve, rotameter is there. This arrangement can be seen in this flow diagram. This is P&I diagram. Actually, over this, above this, one overhead tank is there. This is the tank, overhead tank. This is the overhead tank. This tank is filled by a pump. pump is here. The behind this sump, this is the sump. Behind that sump one pump is there, that will pump from the sump to overhead tank. And this pump will pump always more than required. More than required. That's why always there will be overflow. For that one overflow tube is there. This is the overflow tube. That is in the top of the tank. If any excess inflow means that will drain through that overflow. That is again come to sump. Again come to sump. This is the overflow tube. Here it's here. That overflow tube is there, that will drain excess pumping. Always it will excess pump. Why, we will see later. Why we have to excessively pump, that we will see later. The output of this pump, output of this overhead tank is connected to the valve through this rotameter. This is the rotameter, already I told. This is the rotameter. This is the float to indicate the flow rate. Always it should be connected to bottom of the rotameter. Again, it will be the flow rate inside the rotameter will be against gravity always. So the outlet is connected to the valve. There are 3 tappings, one to the first valve, second valve, and third valve. That's all. This is the arrangement. Before this pneumatic valve, there is one hand valve is there. This is the hand valve. Like our home tap, you can adjust the flow rate by using that inlet valve, three inlet valves. That is manual valve. After that, it is connected to the valve. Output of the valve is given to, here you can notice, output of the valve is connected to, given to sump. So all the 3 valves outputs are given to sump. 1, this is 1 here, 2 here, 3 here. 3 outlets connected to the sump. This is the arrangement. How to open the valve? To open that valve, we need a pneumatic signal. That's why there is a compressor is available. Small compressor is available. Compressor is available. So that is connected here. Small compressor. That compressor is working on 230 volt power supply. That compressor gives about 20 psi. That can be regulated to 3 to 15 psi by using a air regulator. You know, fan regulator. You can adjust the speed like that. We can adjust the air pressure 3 to 15 psi. That is called the air regulator. You can adjust. That output of that air regulator is connected to each valve. Here it is connected. Here it will be connected in the bottom. So you can use one valve at a time. You can use only one valve at a time. That's all. This is the arrangement. Now we have to study the behavior of the valve, whether it works linear or whether it gives equal percentage, whether it gives quick opening. This is the characteristics. Linear valve means the lift 0 to 100% lift. If the 3 to 15 psi you are giving, suppose air to open means for 3 psi 0%, for 15 psi 100% open. That is in the x-axis. Y-axis flow rate. That is also in percentage 0 to 100%. Linear valve means it will be at 45-degree line. That's all. This is linear valve. For equal percentage valve, initially it is slowly increasing. After some time it is exponentially increasing. Quick opening means initially it is exponentially increasing. After that it is exponentially increasing. Then it is saturation. So the 3 types of valves. I already told you that this characteristic is called inherent characteristics. Inherent characteristics. Now let us see what is mean by inherent characteristics and installed characteristics. There are two types of characteristics. One is called inherent characteristics. The valve will be called by inherent characteristics. Inherent characteristics linear means it will be called as linear valve. Inherent characteristics equal percentage means then a valve is called equal percentage valve. Inherent characteristics quick opening means it will be called as quick opening valve. So it is based on inherent characteristics. Inherent characteristics means if the pressure drop across the valve is constant means then it will behave like this. The valve is designed such a way that if the pressure drop across the valve is constant, it behaves like this. But while installing, this we cannot expect this type of characteristics. Why? That we will see now. Suppose already I told you that this tank is always get inlet excess of requirement. Suppose this valve can give an outlet of 600 LPM means liters per minute it can drain maximum means this will pump about 800 or 700 LPM. Always this pump will pump because we have to give excess because the tank is always full. If the tank level varies, the inlet pressure will vary. Are you able to understand that point? The tank level varies, the inlet pressure is where this point is inlet. Here it starts from the tank, it is connected here, this pipe is connected to the valve. That's why inlet of the valve starts here. After the tank, inlet of the valve starts here. So that pressure must be constant. Inlet pressure must be constant. Then only we can do the experiment. That's why the overhead tank is designed in such a way that always it overflows. It overflows means level always in the tank is constant. So inlet pressure is constant. Inlet pressure to the valve is constant. So it comes this way. Finally it enters this valve. Let us assume that it enters quick opening. So this tank is designed such a way that the overflow is there so that the tank always full. So inlet pressure will be constant. This is the point at which the flow rate enters. That is called upstream pressure. The pressure at this point is called upstream pressure. Upstream pressure. The pressure at this point, here it goes to sump, open to atmosphere. This is called downstream pressure. Downstream pressure. Downstream pressure. Here we made upstream pressure constant by using a always full tank. Always full tank. While doing experiment, always the tank is full. That's why upstream pressure constant. Upstream pressure constant. Downstream pressure also constant. Why? It is open to atmosphere. Downstream pressure is open to atmosphere. Upstream pressure constant, downstream pressure constant. Can we expect pressure drop across the valve constant? Yes or no? Why? Because there is a pressure drop in the line. There is a pressure drop in the line. That is called a line drop. This can be assumed like the wire has resistance. That's why long transmission line means there will be a voltage drop in the line. Like that here also the line will absorb the pressure. Pressure will be dropped in the line. The line, the pressure will be dropped. Some amount of pressure will be dropped. That is function of flow rate. The pressure drop in the line. Drop in the line proportional to flow rate. The pressure drop in the line is proportional to flow rate. For 100% opening, what is the flow rate? 100% flow rate, maximum flow rate. For 50% open, 50% flow rate. For 25% open, let us assume 25% flow rate. So, as opening varies, the flow rate varies. As flow rate varies, the pressure drop in the line varies. Pressure drop in the line varies. So, the pressure drop in the line is function of flow rate. Flow rate is like current. If current varies, drop in the wire will vary. Like that, the pressure drop will vary. That's why the pressure just before the valve varies. Pressure just before the valve. Where the flow rate enters the valve here. Here, it enters at this point. It enters here. In this valve, it enters here. It enters here. The pressure at that point varies, depends upon the flow rate. But downstream pressure is constant. Downstream pressure is constant. Therefore, pressure drop across the valve is not constant in an installed condition. If you install the valve, because of line drop, pressure drop across the valve is not constant. Therefore, you cannot expect a constant pressure drop across the valve. The pressure drop across the valve will vary, depends upon the flow rate. That's why you cannot expect from the linear valve linear characteristics. The characteristics will change. The characteristics will change because of line drop. It is function of flow rate. It is function of flow rate. If flow rate changes, the pressure drop changes. That's why the pressure drop across the valve is not constant. Pressure drop across the valve is not constant. Therefore, you designed a linear valve. Linear valve means what? If the pressure drop across the valve is constant, then it behaves like linear. If you install that, the characteristics will be looking like this. This is linear valve, not linear characteristics. Linear valve characteristics under installed condition. Under installed condition, linear valve becomes quick opening. Linear valve becomes quick opening. It is like quick opening. Equal percentage becomes linear. Equal percentage moves upward. Always it moves upward. That's why equal percentage becomes linear. Equal percentage becomes linear. Quick opening becomes more quick opening. Quick opening becomes more quick opening. So this is that's why in industries they will use equal percentage. They won't use linear valve. If they use linear valve, in installed condition it becomes quick opening. That's why, that is the reason why equal percentage valves are required. Equal percentage becomes linear. That too, the equal percentage becomes linear depends upon the length of the tube before that valve. If that varies, its characteristics also varies. The length is excess, then it becomes quick opening. The length is less means it is between linear and equal percentage. The very less length between overhead tank and valve means it is between linear and equal percentage. The length is too much, then it is between linear and quick opening. So anyhow, its characteristics moves towards linear. It moves towards linear. Linear moves towards quick opening. Quick opening becomes further quick opening. Quick opening becomes further quick opening. So how to obtain inherent characteristics? Inherent characteristics means we have to keep the pressure drop across the valve. In this system, we can obtain both inherent and installed characteristics. Installed characteristics you can easily get because you can allow to vary the pressure drop and you can get the response that is quickly. But how to get inherent characteristics? For that, we have to keep the pressure drop across the valve constant. To find the pressure drop across the valve, there is a single column manometer. This is called a single column manometer. Single column manometer. You know YouTube manometer. YouTube means a double column. Double column manometer, you know. Single column manometer is only one column will be there, other end will be connected to pressure end. Other end will be connected to pressure end. So this single column manometer, other end is connected to pressure, where we have to measure pressure just before the valve we have to measure. So that end is connected to just before the valve. Depends upon the pressure just before the valve, the water column in the single column manometer will be there. Depends upon the pressure. If the pressure just before the valve is atmospheric pressure, means in that column 0 level will be there. The single column, what is the pressure? 0, because the other end of this manometer is open to atmosphere. Open to atmosphere. This end also at atmospheric pressure, means no column. The pressure is more, there will be a water column. That there is a scale will be there. One scale will be there to measure that height of that water column. One scale is placed here to measure height of that water column. So we can know the pressure in terms of water column. You know YouTube manometer with mercury field. So there you will tell the pressure in terms of millimeter of mercury, millimeter of Hg. You studied in school days. I don't know where you studied. When you studied here, lessons. Okay. You can study in terms of millimeter of Hg. You will tell. Here millimeter of water column also you can tell. Whatever the material in terms of that you can tell. So millimeter of water column you can tell. So this has to be constant. This level must be constant. To make this constant, what we can do is, when this water column will be minimum for 100% open or 0% open. When it will be minimum, pressure drop in the line must be maximum for minimum water column. So the pressure drop in the line is, most of the pressure is dropped in the line, means just before the valve less pressure. So water column will be less height. So when the pressure drop in the line will be maximum for maximum flow rate, for 100% flow rate, the drop in the line will be maximum. That time the water column height will be minimum. When you reduce the flow rate, this column height will increase. This column height will increase. From that you can understand that the pressure drop just before the valve is not constant. It is function of pressure drop in the line, that you can understand. If you vary the flow rate, the column height varies. Column height will vary. But it will be minimum when the flow rate is maximum. It will be minimum when the flow rate is maximum. That's why, suppose, let us assume that for maximum flow rate, the water column is 50 mm. I do not know what is the value. Let us assume that 50 mm. I didn't remember. Do you remember? 50 millimeter, let us assume. 50 millimeter or 50 centimeter, right? 50 mm, let us assume. 50 mm for maximum flow rate. If flow rate decreases, this will go up above 50 mm. This will go up above 50 mm. I understand that point. So it will go up above this 50. It will go up above 50. To keep this 50, there is one hand valve is there. If you close that hand valve, the hand valve introduce additional pressure drop. The hand valve introduce additional pressure drop. Flow rate is less, means less flow pressure drop in the line. Additional pressure drop can be introduced by that hand valve. 1, 2, 3, 3 inlet valve is there, hand valve. 1, 2, 3 hand valves are there. If you introduce additional flow rate, you can bring back to that same level for maximum flow rate, same level. Whatever may be the flow rate, you can keep the level for maximum flow rate. So let us assume that for maximum flow rate 50 mm, we assumed. If flow rate is decreased, then this will go up. By adjusting that hand valve, again you can bring to 50 mm. Therefore, by adjusting the hand valve, you can keep the pressure drop across the valve constant. You can keep the pressure drop across the valve constant. By keeping the pressure drop across the valve constant, you can opening this valve from 0 to 100%. You have to measure the flow rate through this valve by using this rotameter, and you have to note down for 0 to 100% opening, what is the flow rate through this rotameter. You have to note down. If you plot that, if you keep the pressure drop across the valve constant, for linear valve, it will give linear characteristics. It will give linear characteristics. How to get installed characteristics? Don't adjust the hand valve. For maximum flow rate, it will be 50 means. For other flow rates, it will go above 50 mm. It will go above 50 mm. So you can understand that there is a change in pressure drop across the valve. For that, what is the characteristics? You have to note down the rotameter value. That's all. That's all. Like that, you have to do for 3 valves. That first valve is air to close. So if you didn't give any air, what will happen? It will be 100% open. The first valve is air to close. So inlet is the top side. That's why air to close. If you didn't give any air pressure, it will be 100% open. So if you give air pressure, then it will close. Other 2 valves are 100% closed. 100% closed because air to open. So if you give air pressure, then only it will open. You can note down the lift here. You can note down the lift here. You can note down the lift here. How much it opened, you can see here. Based on that, you can draw the characteristics. You can draw the characteristics. That's all. Before doing this experiment, you have to find the control valve characteristics. Already I told you that the control valve is the flow rate equal to the flow rate F. Flow rate is proportional to pressure drop across the valve. Pressure drop across the valve. Flow rate is proportional to delta P across the valve. So the pressure drop is kept constant, and you can find this is proportional only. To make it equal, the flow rate is equal to CV times square root of delta P. CV times square root of delta P. CV times square root of delta P. To find CV, what we have to do is, we have to open the valve 100%. For 100% opening, what is CV we can find? So, open the valve 100%. What is the delta P that you can see in that water column? Millimeter of H2O you will get. From that you can find the control valve coefficient. Control valve coefficient. That is the first part of the experiment. You have to find the CV for each valve. First valve, second valve and third valve you have to find the CV. Each has 400 or 600 LPM flow rate. Some valves are for 800. The first one is I think 800, 600. Other 2 are 400 I think so. There it will be mentioned. Yes. For quick opening 600 LPH. For linear and equal percentage 400 LPH, liters per hour. So for you have to fix the maximum flow rate. You have to fix the maximum flow rate. For that, what is the delta P you have to find? Once you know the delta P, you can find CV. Once you can find CV. How to obtain inherent characteristics? By keeping the pressure drop across the valve constant. The pressure drop will be minimum when the maximum flow rate. That's why that minimum flow rate will be kept for all openings by using the hand valve. So that we will get the equal linear and quick opening and equal percentage valve. Inherent characteristics you will get. So how to do experiment? First you do inherent characteristics. Before that you have to find the CV, so that you know the maximum flow rate. Suppose for linear valve maximum flow rate is 400 LPH. Keep 400 LPH and find the CV. That's all. Then for that, what is the water column? Note down. You adjust the valve opening by adjusting the regulator. Already I told you how to adjust the valve opening by adjusting the regulator. Where is that? This is the regulator. This is the regulator. Here in the diagram, P&I diagram, this is the regulator. Here it's here. This is the regulator. By adjusting that regulator, you can adjust the flow rate, air flow rate, 3 to 15 psi, assume. But it may be higher than 15 psi because the valve may require more than 15 psi, means it gives. So by adjusting this regulator, air regulator, you can adjust the air supply so that the flow rate is 400. For that, what is the water column? The pressure drop across the valve in terms of water column, you note down. Then adjust the valve opening by looking at this travel plate, that is the scale to indicate the valve opening. There you note down the valve opening, take down the flow rate. That's all about inherent gas by keeping the water column constant. Next experiment is keep 100% open, then note down whether it is 400 liters per hour or not. If it is 400 liters per hour, then you vary the valve opening. That's all. We are not going to adjust any pressure drop. Then water column also vary. At the same time flow rate also vary. Kinetics is also vary. If it is linear, means it becomes quick opening. If it is equal percentage, means it becomes linear. If it is quick opening, means it becomes further quick opening. That's all.